complex numbers. A complex number consists of a real part and an imaginary part. So the real part is the number you can obtain on a number line. And here you have an example of a real number line. So 2 is a real number. You can locate 2 on the number line. You can count 2 objects. But you have what you call imaginary numbers. It is given the letter I. So I is a number. Bear in mind, it is not the only time that letters can be used to represent numbers. The Romans used letters for numbers. V is the number used to represent the number 5. X is representing 10. So I know is a number, but it's a very, very interesting number. It's the square root of -1. Bear in mind, the square root of 25 is a number, which is 5. The square root of 49 is equal to 7. The square root of a negative number, if you want to obtain the square root of a negative number, if you want to obtain the square root of -1, you're actually asking what 2 numbers, when multiplied, would give you -1. Example, the square root of 5 is 5. The reason why the square root of 5 is 5, because if you take 5 and you multiply it to itself, you get in 25. And the fact is that a negative number times a negative number is a positive number. -5 times -5 is 25, positive 25. So therefore now, anytime you multiply a number by itself, the answer will be a positive number, be it negative or positive. A negative number times a negative number is a positive number, such that all square numbers are positive. Now, if you're trying to square root a number, you're trying to find a number that was multiplied to itself to give that number. But if you think of it carefully, if you're trying to square root -1, you are trying to find a number that was multiplied to itself to give -1. What number that was multiplied to itself to give a negative number? When in the first place, 2 numbers multiplying to itself must be a positive number. So that's like a conundrum, it's like a paradox. And that's why it is called an imaginary number. It's a number that you cannot hold. You cannot use it to count physical objects, but it's a number nonetheless. And it's given the letter I for imaginary. However, it has its applications, and it is even as real as any number on the number line. Okay. And that is what, when it's combined now with a real number, it's called a complex number. So let's see what this website has to offer. Let's click on it. The Python complex function converts the string of numbers into complex integers. If you look at the syntax even below, you can see that the complex function takes 2 optional parameters. First, a real. So that's what this website is offering. So it's a specific app, it looks like. So this website is not so helpful with regards to giving us examples of complex numbers. So you can simply type in Google examples of complex numbers. And here it goes again and says complex numbers are numbers that are expressed in the form of a plus ib. I is representing the imaginary number. Okay, B is a real number, but I, that's the imaginary part because you have I by it. So for example, 2 plus 3i. 2 is the real number, but 3i is the imaginary part. When you combine them, you have what you call a complex number. So what I'm going to do, I'm going to get a website that can add more information, complex numbers, and you can use YouTube also, the real part and the imaginary part. Here is a nice website that gives you some extra information and it gives you clarity. So I can add that to the unit and the assignment. So I'll put it first. I'll give precedence over this one. I probably can even take this one because this is an app. And it's Google Docs, so it will automatically update. I will use it also once in the unit. So one example. Here, yeah. Okay, click on take. Oh, look at there. Right. So an example now would be like and actually goes on even more detail because imaginary numbers gives you what you call a sense of direction. That's why it is used extensively for interstellar travel. The space rockets and so use it, depend on it a lot to facilitate space exploration. So 3 plus 4i is an example of a complex number. You have the real part and the imaginary part. Represent visually, you have the real axis and the imaginary axis, not x and y, the real axis and imaginary axis. And this is the number. You see that line? It's like a vector, it's like a line. So it's not a number to count. It's a number to navigate, if you want to put it that way. Okay, so this is the number. That whole thing there is that complex number. The real part and the imaginary part combined to give that number. So an example would be like 3 plus 4i, you have 9 plus 8i. You must have I in the imaginary part. So coming back to the assignment, an example. So you can write example in terms of the question itself. You can give your own example. I might even do that for all the questions as we go along. Example of a complex number would be is, let's see, 8 plus 12i. You can put the I in italics or you can leave it as straight up. But most times it's advisable to put in italics. If you're using Google Docs, you can go in insert and you can go in equations. And if you type it, it will put letters. That's like the standard for mathematics. Writing letters are normally written in italics when they are variables. And a brief explanation, you can explain your real number, your complex number. Okay, a brief explanation. So you can see the real part, it, and the imaginary part, Li. You can copy this part there so that the italics. So it could be one sentence. And if you decide, well, you want to say a little bit more, you do a little research again. And here you have properties. Okay. What it says, you can read. I don't want to go above the level of difficulty, above the limit of the course. It says, so the complex number 3 plus 4 can also be shown as a distance, 5 and angle. So that's like the calculation, because remember, you can apply trigonometry to calculate the distance between from here, from the origin to that point. But we don't want to go right there. Okay, that's, remember, the purpose for this course, right? So you can, that's why you can keep it like what I just said. You can keep it brief. Okay. So you don't have to go deep into, but there's a lot to this. See, because this is a right angle triangle, you can apply Pythagoras theorem, you can apply tan, because you have the vertical and the horizontal. And this angle there, you can calculate this angle using tangent. That's what this is saying there, and you can write it in polar form. But we don't have to go there. Okay. If you can do some drawing, I don't know, you can represent it in on the graph you would like to, up to you. How can you do that if you want to use Google Docs? You do have to be drawn to scale. So that's the real part, that's the imaginary part. You have it on the real part, so you can write it anywhere there. This is it on the real part, and then you have the imaginary part. So it's up to you. You can decide how far you want to go with this, but one sentence suffice. Okay, because you are not here to study mathematics specifically. Now, you draw the point, circle. Oh, it goes somewhere right there. And you know that's the imaginary part. That's the imaginary part right there. Imaginary. And that's the real part down here. And that line, you can include the word vector, is that number. So all of that constitutes the visual of that complex number. Save and close. And then you have the example of your complex number. It's saved it down here. Can you bring it up here?